Okay, good evening, everybody. Welcome to another Our Universe Revealed. For those of you who haven't met me, I'm Jonathan Crass, the series coordinator. And whether you're joining us in person or whether you're joining us online, it's very good to have you with us this evening. It is my pleasure tonight to welcome back Professor Graham Peaslee to Our Universe Revealed. How many of you are Notre Dame football fans? Start that, okay? How many of you watch the games in the stadium? How many of you watch them at home? Okay, depends on the game and the weather. Well, no matter whether you've been in the stadium or you've been at home, Notre Dame has a series called What Would You Fight For? And Professor Peaslee was highlighted on this last year. Is that right?
Year before.
Year before.
Last year.
Where he talked about how it is important that we look for chemicals that might be impacting human health, impacting the environment, in particularly PFAS. And he's going to talk all about that tonight. I do encourage you to look at that video online on YouTube. If you've got the emails for the series, it's there. It's very emotive. A lot of the problems that Professor Peaslee's been trying to solve since he started here at Notre Dame 5.5 years ago. So without more ado, you don't need to hear more from me. Over to Graham. Let's give him a nice warm welcome.
Thank you, Jonathan, and thank you for coming out on a cold night and listening to one more series on PFAS. I'll be here for the next 500 years or so talking about it. It's the forever chemical. And what I thought I'd talk about a little bit more tonight, I'll go into some science, but I also would like to go into policy and how science interacts with policy, which may be interesting to some, but it's absolutely terrifying to most of us scientists. And I'd like to describe a little bit about how my research has impacted policy and why I now do it, because I can. And so I'll talk a little bit more about that. I'm going to keep it relatively short, so there's time for questions, and you can also boogie out as need be. But we have a couple of examples of public health disasters in this country, and this is only two of several. Okay, you can think of others on your own, but these are two that I've been I've been involved in at some level, and I still am. And then I'd like to talk about one that I think is happening at this very moment. These other two are happening as well, but less so. The perfluoroalkyl substances is going to be probably the greatest environmental challenge the U.S. has faced. And I make that claim kind of broadly at the front, and you can talk to me afterwards if you disagree. But I think that this is going to be something that we're all going to hear about, if you haven't already. And in conclusion, I'm going to sort of reflect on what a scientist can do to try and influence policy and why it's necessary that a scientist does such things, not just stand in the lab and study these things, but actually talk to people and try to communicate not just the science, but what should be done because of the science. And there's a real pushback about science-based reasoning in this country. And I think it falls on all of us to try and counteract that with science and with what should happen as a result of science. And I'm going to try and weave that in with a couple of examples. So I'm going to start with a story that's a book title. It's called The Poisoning of Michigan. How many people know about the poisoning of Michigan, have read this book? Absolutely none, and I can read online too. It's not a big seller. In fact, most of my talks, I don't get invited back a second time because it's kind of a doom and gloom talk about some environmental toxin that's killing us. This is no exception. This was in 1972, 73 when most of it happened. Anybody know what happened in the US in 1972 and 73? There's a couple people back there old enough. Anybody remember what happened in 1972 and 73? There's this thing called Watergate. And there was a Vietnam War going on and a few other things like that. People were distracted, and it was the 60s were over and people were kind of depressed. There's lots going on. And there's a small town up in Michigan called St. Louis, Michigan, an odd name. It's just about there in the middle of nowhere. It's farm country. But there's a river there and there's a chemical plant. And that chemical plant proceeded to have the largest mass poisoning that I know about in the US. Okay, 9 million people were poisoned. And I dare say that nobody here knew about it. Okay, even though some of you may have Michigan roots and in fact be impacted by it. This is a book in Michigan State University Press. It's available on Amazon. You can deliver it for $19. And it's actually, for the first 5 chapters, a pretty good read. It falls apart a little bit at the end. But Joyce Eddington was a British BBC reporter stationed in the US that time. And she went out to cover the story as it happened with a few other reporters. And all the other reporters failed to report it. And so she was really confused by this, by nobody was paying attention because she thought it was significant. But, you know, the Vietnam War or Watergate were on the top of the press. So she wrote a book about it, came out many years later in 2009, about sort of the epic fail that happened. What happened in this plant is something called a polybrominated biphenyl. And here's a chemistry lesson. For those in organic chemistry, we're just in this room in the last hour. There's the two aromatic rings and a lot of bromines. And this thing had the capability, it was a brand new discovery in those days. It had a lot of electron withdrawing groups in these bromines that could suppress ignitions of fire. So this was a flame retardant. They had no other idea in the 1970s about safety of these things. It turns out to be extremely toxic. It's a terrible thing to have out there. But they made it and they were starting to use it. When we do these organohalogens, that means they're an organic compound attached to one of those chlorines, fluorines, or bromines in this case, iodines, any of those sort of bonds like that. And there's lots of examples. DDT, okay, that's a famous pesticide that almost won the Nobel Prize for Medicine. It was considered for the Nobel Prize for Medicine because it almost eradicated mosquito-borne malaria. But DDT also got rid of almost all the lower 48 eagles at one time, and the famous Silent Spring that was written by Rachel Carson in 1962 was based on the effects of DDT in this country. And it was then banned, and whoops, well, no more Nobel Prize for saving so many lives. It actually caused a lot of environmental heartbreak. The decabrominated one, those are in all our circuit boards. Even today, if you have a computer or a Samsung that doesn't blow up, you have something like this embedded in that circuit board. And these pentabrominated diphenyl ethers is what was a replacement for those polybrominated biphenyls that I just showed you. They're all in the same category. They're all terribly PBT. That means persistent, bioaccumulative, and toxic. Okay, sort of the triple whammy. They last for a long time in the environment. They last for a long time in your body. They bioaccumulate, so if you eat some, you're stuck with it for a long time, and then you eat more, it just builds up. And if something eats you, a little small fish being eaten by a large fish, it'll bioaccumulate that way. So if you eat something that ate this product, you would get it, and you'd have more of it. And it's toxic because it attacks, in this case, the liver and the reproductive system. And it's an endocrine disruptor, as well as just a toxin to the liver. So there are only 21 globally banned chemicals by the or Stockholm Convention on Persistent and Organic Pollutants. All 21 of them are organohalogens, this class of chemicals. Okay, so we know they're bad. We know that they have bad effects. But in 1972, we were gleefully making it as a flame retardant. And the company made these things in big red bags, red and white bags called Firemaster, and had big signs on it, Firemaster. And it made magnesium oxide in a brown bag with blue labeling called, magnesium oxide was similarly discovered the previous couple of years to be a food supplement, a vitamin that you gave to cows. And it increased their milk supply, which for a dairy farmer meant a 30% profit margin. And in a dairy state like Michigan, where I have a lot of cows, you got the Michigan State Extension found that if you gave cows vitamins, their milk supply became more healthy. They were better milkers. And all the farmers were having this wonderful discovery. They added magnesium oxide into the cow feed, and you had a better crop, i.e. more dairy milk. So this was being manufactured at one end of the plant, and that was being manufactured at the other end of the plant. But this was in a red bag with white labels, and this was in a brown bag with blue labels. We're all good. But then, unbeknownst to them in 1972, there was a strike at 5 out of 6 Canadian paper mills. The laborers wanted more wages. They went on strike. Johnny Carson, who was a late night host in those days, got on the TV that night and said, we're going to have a shortage of toilet paper next week. And what happened? Everybody ran to the grocery store to buy toilet paper, so we didn't run out. We didn't run out of toilet paper, but we ran out of bags. Okay, there were no more paper bags. There were some brown ones available. There was no more printed brown bags or printed blue bags or white bags. So we just did brown bags for this company for a couple of months. And there's handwritten on them, Firemaster and Nutrimaster, which were their two products at this chemical factory. So they all became brown bags that looked like that with handwriting on it. Probably not the product of Canada on it. It was a product of Michigan. But I found that on the web. And lo and behold, a truck driver arrived that didn't speak English that day. And he went to one end of the factory and got some brown bags with something master written on it and delivered it to the Farm Bureau. Guess what he did? He mixed up about 17 50-pound bags of Firemaster instead of Nutrimaster. They're small yellow pellets, looked like the same thing, yellow or white. They got mixed into the feed, and the cattle started eating it in the spring of 1972. And it took 12 months to identify that had happened, and it took another 6 months to stop happening because it had gotten into the contamination. The cows got very sick. It was delivered to this Battle Creek distribution center right there. Indiana was saved because the Michigan Farm Bureau feeds Michigan dairy farms, not Indiana ones. So it was sent all over Western Michigan, but certainly some of it, maybe not so much the UP, but the Upper Peninsula and down here, all got feed stock from that Battle Creek plant shipped all over the U.S., shipped all over the Michigan, sorry. And what happened was the cows started getting very sick. It was mixed in with the feed. The cows ate it. You can see here in a bad photo, the hoof of the cow started growing at 1 inch per month, and they started curving. The cow's teeth fell out. The cows started dying. They started losing weight and dying. They didn't milk at all. They were milking much less. And the cows were observed to, come out one morning and find half your dairy cattle weak or and the farmers complained that something was poisoning their cows. And the Michigan Farm Bureau said, no, this is a supplement. You guys are nuts. You're just not doing animal husbandry correctly. So the Farm Bureau denied it. Michigan State Extension said it was our good idea, but that's not what happens. And they went on, and it took a retired farmer, actually, who was retired from Dow Chemical, to figure out, he sent the samples out to Iowa to be analyzed. And finally, they found out that there was a flame retardant in it. Unfortunately, by that stage, all the meat from these cows and all the milk from these cows had been distributed across the state of Michigan. And in fact, this is the population of 9 million people. And we had our own delivery system to all the most vulnerable population. And it got into everybody in Michigan. Maybe a little less up here, but there weren't many people up there. And so all 9 million people ended up for 18 months eating milk and meat. And at the end of that time, there were bans. All the adjoining states of Indiana, Wisconsin, Ohio had banned Michigan products because of this, and it was known. Okay, it was removed, and eventually, after 6 months later, everything cleaned and it went away. However, the farmers were out of luck. They had bought this. It was discovered what it was. The state of Michigan realized that there were, a few dozen farmers that had done all this, but they had poisoned 9 million people. They had no way to indemnify 9 million people if they had claims. So they paid off a couple of farmers a few pennies on the dollar for their cows, but most of the farmers had an ethical choice what to do. They could still sell the meat legally. They could drive it to Indiana and sell it and make all their money back. But they knew that their own family had gotten sick from eating the cows and the cow's milk, the cheese. And so what they did is they went out in the field with high-powered rifles and shot their livelihood. They took their $300,000 worth of cows that year and shot them in front of TV cameras to make a point. They drove their tractors around Capitol building in Lansing. They went out to a field and they shot their cows publicly in front of people because they're making the ethical choice. I can make some money back on these cows if I just sell them, but they knew ethically not to do that. And most of them did this, not all. A couple of them got out of the business. Several of them went out of business. A couple of them survived. It was a big disaster. The state then took over and made 2 burial sites up here, unlined burial sites, incidentally. And they took 30,000 cows, 6,000 pigs, 1.5 million chickens, eggs, and other dairy products, and buried them in 2 sites, which are now leaking polybrominated biphenyls. But those are now out of circulation. They cleaned up the equipment, and it went away. But what happened to those 9 million people? And what happened to the children of those 9 million people? Because this is an endocrine disruptor, the children of those people that were poisoned will also have damaged reproductive systems, for example. And so there are many studies of early onset puberty, of miscarriages. Miscarriages wasn't statistically significant. One of the problems is that they took this area, which was highly impacted, and compared it to that area, which was less highly impacted, but not 0. So they didn't have a control group. What they should have done was taken a group down here, which had 0. But they didn't think of that at the time the study was done out of Emory. And that was done in 1972. It goes on till this day. It's still ongoing. They're still studying some of those people. But again, the control group was not well controlled. So the things were undone. So this is what one of my students described as an epic fail. It was a failure of the company. Who in their right mind would make a hazardous chemical at the same building as a feedstock? It was a failure of the distribution system to recognize it, to test for it, or to logically correct for it. It was a failure of the regulatory system to oversee such things. Okay, it was a failure of the press to report it. It made a couple of newspapers. Some farmers got together and shot their cows. They were protesting something. That was the baseline of most of the stories in the papers. Okay. And then it became, well, don't eat the meat. All right, something else is wrong with the meat. And then it went away next year. Okay, even before it was cleaned up, it went away. And so a few people know about it. This book describes the detail of it. It wouldn't have even come to light unless a couple of lawyers got involved and threatened to sue. And they were pretty quietly shut down. The president of that time was Gerald R. Ford. And guess where he came from? Grand Rapids, right there, 2nd District of Michigan. And he wasn't even told about this because he had bigger things on his mind with Watergate and other things. And so he had taken over for Richard Nixon that year, but even the political system just failed. There was just a failure at every level. So we read this as a book in one of my classes I taught, and people said, that's too bad, my parents' generation. But it couldn't happen now, could it? Let's fast forward about 40 years. Brominated flame retardants are widely used in home furnishings. You don't have much here, but you have an entirely plastic chair. But all those chairs with cushions that have polyurethane foam in them, in your house and your couch, they have about 3 to 6 weight% of a brominated flame retardant, or now a chlorinated flame retardant used in them. Well, they did for many years. That means in a typical couch, you'd have about 1 pound of this stuff. And what's the lifetime of a couch? Anybody know? It lives in your living room for 10 years. Everybody sits on it, dogs play on it, cats live underneath it. Okay. Then it goes to the college dorm with your child as they move out, and you get a new one. Okay. It lives there for another 4 years or 5 years, depending on how quickly Johnny graduates. Then what happens? It goes to the fraternity and lives there for another 12 years. Average life expectancy is about 30 years for a couch. And you know what the dorm couches look like after about 12 years? Yeah, they're getting pretty ratty. All that foam is coming out, and with it, a pound of flame retardants. There's an epidemic in this country called feline leukemia, which is actually not leukemia at all, but a type of cat disease of the liver, of the thyroid, which is probably due to brominated flame retardants in cats. We don't have national veterinary records, only state by state, but almost every state's recording this thing. And what we discovered is if you look, it's all due to this California Home Furnishings Bureau Technical Bulletin 117, because of a BART fire, the Bay Area Rapid Transit Fire in 1980 or 1978 summertime. They made this requirement that all home furnishings should be resistant to flame, and they put a flame retardant into it. Sounds like a good idea, it might save lives, but we also stopped smoking a great deal in the 70s and 80s, and we also don't carry candles around because this flame retardant is only good against open ignition sources. If you have a gasoline engulfed fire, it doesn't do any good. Okay, so it's only good if you hold a candle to it. So if you fall asleep with candles on, or you fall asleep with a lit cigarette, well, actually cigarettes in those days are actually made with a self-extinguishing part to it. So if you leave the cigarette smoldering, it'll self-extinguish. If you smoke the chemicals, it's bad for you, but you're a smoker anyway, nobody cares. Okay, but if you have this self-extinguishing cigarette, you don't get any more cigarette fires. So the number of people that die in a couch-started fire is really quite low in this country. Probably less than on one hand, and yet we have a pound of really toxic chemical in each of them. And that toxic chemical comes out with time. Gets into cats, gets into breast milk, we've seen it there, but we also see it here in just the dust. Here's ppm levels in the dust, and look at California, where this is the requirement, and the other states follow along. Other countries which banned this 30 years ago, Germany and UK, has almost none. So how did these states get it? Well, California is about 20% of the US in terms of market size. So if you're going to sell a piece of furniture, you want to sell it to California, you might as well make it flame retardant for everybody because it's too difficult to make two different types of furniture. So this was a state that was going on. We're getting it everywhere. This is 2013 when I started looking at it, and I met a woman who described this to me, and I said, that can't possibly be happening. All my students went dumpster diving. We got pieces of foam out from anywhere. The mosh pit in the gymnastics arena, the car seats. We looked at car seats from every make and model between 1975 and 2007, and we identified where the foam was and which flame retardant was in it. And it's remarkable. There were 3 different types. Then in May of 2012, an investigative report 5-part series that actually won an award, the Chicago Tribune came in with this Playing with Fire series. And they said a deceptive campaign by industry brought toxic flame retardants into our homes and into our bodies. And the chemicals don't even work as promised. And they go on to describe it. And they showed that the industry actually faked some test results saying that this it isn't as effective as it claims to be. It gets you an extra 12 seconds of ignition time if you hold an open candle to it. The number of candle-induced deaths, fatalities by flames in the US is negligible in the modern era anyway. And so this series came out in May of 2012. There had been attempts to overturn the law in California 7 times at this point, based on science, saying it's really not necessary to put this chemical in there. What happened was in June, 1 month later, the then governor of California suggested resolve that because the 5-part series was looking rather bad. And they went ahead and they made a flammability standard that was higher than the one with chemicals, but it could be done without, it's entirely on the fabric, it could be done without any chemicals. You put a non-cotton fabric on the outside, a synthetic fabric on the outside, and that was a better flame retardant. So that was a higher, safer thing that came to my attention because I'd been studying brominated flame retardants. They're in the Great Lakes. We were looking at them as sediment and in all sorts of places, and we were finding them in all sorts of polyurethane foam. And suddenly they went away because this led to a little label. If you look under anything more recent than about 2016, you'll find this label underneath it. And it says the upholstery materials and product contain no additional flame retardant chemicals. And that was policy I'd like to say came from science, but the science didn't direct it. The science had to go through an investigative news report, and then it changed. Bingo. People care about what they read about in the news. And up until that point, the industry, which consists of 3 companies, 1 Israeli and 2 Michigan companies that harvest bromine. Okay, the Deep Dome, for those geologists in the audience, the Deep Dome in Michigan is actually a salt mine you can get bromine from, or the Dead Seas, you can get bromine from that too. And those are the 3 companies that make all the flame retardants. About 400 employees total put all these chemicals into all of us. Okay, and they weren't intentionally doing it, they were just making a product and selling it. But we know well that science is not the best chemical to be used. So this is an example of science introducing policy. The second one is much shorter, but it also played out in the newspaper. And the newspaper played a vital role in this one. You might remember lead poisoning. Everybody's heard of lead poisoning. What's the most associated name with it? Flint. You remember Flint? That was in the news about the election cycle before last, 2016. Here's the elevated levels of lead in children's blood, around 5 or 6 in those years in 2000, 2003, 2011, 2010, 2000, they're about that. They're going down annually until they changed the water in Flint, and suddenly they went up to 7 or 6% of the children being poisoned from around 3 or 2 before. So you got a huge spike in children's blood lead level in Flint because they changed these corroded pipes with river water, and they forgot to keep the scale on there. The phosphate came off, and the lead got into everybody who was drinking. It was a poor, socioeconomic disadvantaged environment in Flint, these zip codes. And basically it was a poor black neighborhood, and they got a high level of lead, and their children showed it in the next 2 years. People became aware of it. It was a big campaign issue. And the people who ordered it fled the country and left, but the people who actually did it actually served jail time. It was a criminal offense to have changed the public water supply, and they shouldn't have. And they were unfortunately knowing that they did it, but they were ordered to do it by some people who were saving some money. What's bad about lead poisoning is this study that came out in 2012 that showed this is the air lead from leaded gasoline in the US at 6 different major cities, and it went up, and then it came back down, and it was as leaded gasoline was phased out in the late 70s, early 80s. It was actually banned in gasoline, not for health reasons, but because it destroyed catalytic converters. And so we didn't have a health reason for it, but we stopped using airborne lead. On this, if you look at the average air here, you look 22 years later, and you look at the aggravated assault rate in those same 6 cities. The aggravates, this is the number of 800 aggravated assaults per 100,000 population. Big cities have crime. Aggravated assault is one of them. They looked at rape and murder as well, but all the crimes went up and peaked and came back down. This was the peak of violence around big urban cities just before the year 2000. There was an increased police force put everywhere. There was all sorts of worry about this violent crime all over society, and it correlates in 6 independent states. The police forces are not nationalized. They're city by city, county by county, state by state. So as police forces, some of them had gone up, some of them hadn't. So having more police sometimes made it go down. So having more police, sometimes it was still going up, depending on when you got them. Okay, there's no other factor that would relate the entire country going up or down in violent crime, except the presence of lead in atmospheric quantities. It's a correlation, not a causation. You can't cause one, but you can say, wow, it's really highly correlated. It's got about a 0.8 correlation there, which for those of you who do statistics knows that that is really high R squared for any sort of environmental data. Worrisome because what is the total cost? Oh, a few children when they were 4 or 5 have a lower IQ because of lead poisoning. We know that happens. They also have attention deficit. They also have problem learning in school, so they tend to be, and it also attacks the part of the brain that controls impulse. So you have less impulse control. That is a tremendous cost to pay 20 years later when they're young teenagers or young adults. Okay, there's no cause there, but there's enough concern that lead poisoning is a really dangerous hazard for young children with a developing brain. So we know that. We fast forward, and in 2017, there was a Reuters report on, hey, Flint had this lead problem, and we know that children's blood lead level doubled. But there are 15 other cities in the US that also have lead problems. We just found it in the public records. One of those cities was South Bend. This is South Bend. And remember how the lead levels in Flint had gone from 2% to 7%? And that was an alarm and got public media. We looked at the census codes in various areas of downtown South Bend. The university is right underneath that sign. But this area of South Bend, the sixth census district right there, had 31% of the children tested with elevated blood lead levels. Almost a third of the children were lead poisoned. And we had a newspaper store when it went to 6%, 7% in Flint. It is a poor black neighborhood in South Bend. Oops. It doesn't seem to come from leaded gasoline or from leaded water. It seems to come from leaded paint in this case. We formed something called a lead initiative team in Notre Dame to address this, and 7 different faculty members showed up at this meeting, and we all looked at each other and said, hey, we're all working on this. Maybe we should get together. And we did. There's a book about it because lead paint was banned about the same time as lead in gasoline, about 1978. It's no longer in use in residential paint from 1978 onward. Can anybody tell me, this is a Journal of American Medical Association. It's a big medical journal. When do you think the first article saying that a child died from lead paint, maybe we shouldn't use it in paint, came out? It got banned in 78. When do you think that first article came out in this reputable journal? Close. 1914. 64 years earlier. There was a 12-year-old that was killed by eating paint in Kansas. And they made an article up saying, ooh, we should watch the paint, guys. 64 years later, we finally banned it. Why? And I'll give you a counterpoint. Australia banned it in 1915. The residential paint in 1915. Because they read this article and said, whoops, that's not good. But we have an industry that tried to keep lead legal for a very long time. It was a very profitable industry, and they put it in gasoline, they put it in paint, they put it in a whole bunch of other places. It was in Grecian formula, that thing that makes your hair stay not gray, up until 2019, when they decided maybe we should remove that from Grecian formula. Yeah. Okay, so there is a industry behind it. The industry is mostly bankrupt now, the lead one, because there is no really saving grace for lead. It is toxic at any level. We formed a lead innovation team here at Notre Dame, and we have a website and developed a rapid test screening kit by which we can, the way we measure that lead is a problem, lead poisoning is a problem, we test kids with a needle stick at age 12 months and at 24 months. And if anybody's tried to stick a toddler with a needle, you know how much fun that is, okay? Neither the parent nor the child like it very much. Okay, but you do that, and we tested about 17% of all children in 2018, and about 87,000 children were above 5 micrograms per deciliter, which is the current rate, or was the current rate of lead poisoning level by the CDC, and 13,000, over 100,000 children about in this country were clinically lead poisoned. Okay, that's 100,000 people that didn't need to be, but because we keep lead paint on the houses and it peels off, or because we have gasoline in the soils and we track it in, are getting lead poisoned. Sometimes it's from the water supply, but not often in this country. And so we're getting people to test for, but the way we find it is that we screen children. Some fraction, typically those on required to, have some testing. And when we look at that, we can identify if a child presents in the hospital or presents at one of these test sites with elevated lead levels, and they're high enough above, in Indiana, 10 micrograms per deciliter, a person goes to their house with a handheld XRF and scans for what, oh, this chair is leaded, that door frame is leaded, replace them. Okay, but that state intervention doesn't happen until the child is poisoned. Oops. Okay, so we've proposed, and our innovation was, it's so cheap, and it's 70 years, well, 30 years past when we first developed this technology. We have a cheaper technology. If we engage the community in testing their own houses, we can run the samples here, run the XRF on it, and we can test 10 times faster for lead in the home. And we do. And we send them the resident who sends in the sample, we send the report back to them, and they can decide what they want to do. We send them links to what's available to help fix, what short-term remedies and what are long-term solutions. And we connect them with resources in the state. And by doing that, we've actually helped the county save money because they don't have to send somebody out with an XRF all the time, except if there's already a test saying, yeah, there's lead in the house. And we ask the metadata, are there any children living here? Yeah. So let's have your child tested, and then that'll get the state involved. But even with our screening kit, the county health department will now respond because we've done a screening. We have developed this little kit that goes home. It's low cost. It's quick. We can just scan the results here and with our instruments, and it's scalable. We can do this. We've got a HUD grant, the first HUD grant Notre Dame ever received, to scale this to 3 counties in Indiana: Marion County, which is Indianapolis, St. Joe County, and Vermilion County, which is a rural one. What's nice about it is that it's really timely, because just last week, the state of Indiana has announced that they're going to get with the rest of the country and lower the lead levels from 10 micrograms a deciliter to 5. That means we will now tell everybody that it's 5. Unfortunately, the CDC just lowered it 3.5 for national. But we're only a decade behind. We'll catch up. And so this is what we suggest will be the new limit. Of course, whatever thousands of children are lead poisoned now, we suddenly have 5 times that number next year, because we're going to lower the limit of what lead poisoned is. Remember that any level of lead is really bad. So having a measurable level is not good. But this is a cautious step. We've got extra $50 million in the Indiana budget to deal with it, and it's going to be done. And we hope to play a role in this because our lead testing kit will do that. Again, difference in this one is that there's, again, no publicity about lead. Everybody said the lead problem was solved in the 80s, right? We got rid of it. Well, we did, but lead never goes away. It's an environmental toxin that just sort of sits there on the dirt. It's still in the dirt. If you eat that dirt, you'll still get poisoned, even though the car has left it there 30 years ago or more. Now I'll get to the fun part. Those are examples of where failures have happened, where we've dealt with it. There's always an evil company involved, but only one. Most companies do the right thing. Here's another one. These are per and polyfluorinated alkyl substances. It's a mouthful. It's a type of category of where you have an organohalogen again, carbon in the gray, and the green ones are fluorine, and they're kind of funny looking molecules. Those ones have eight charcoal ones in the middle, and those are P4 and PFAS. The octo stands for 8 carbon, C8. And there's a book out, Stain Resistant, Non-Stick, Waterproof, and Lethal, C8 chemistry. And this was what broke in the early, I'd say in the early 2010s. A non-stick cookware plant in West Virginia was discovered to have this leaking into the water. It's the primary ingredient, or one of the things you make with it is Teflon, or Teflon jackets like Gore-Tex, those Gore-Tex jackets, or firefighting foams. That's bad news, because firefighting foams, they do put out fires quickly, but they also get into water, and they're soluble, and we drink them. They're in Scotch-guarded carpets. Anytime you see the word Scotch-guard, and we all grew up on Scotch-guarded carpets, you can dampen up the wine with a damp rag, and it comes right off. It doesn't stain anymore. And it's, of course, in all our microwave popcorn. Why is it our microwave popcorn? Yeah, the lining of the bags are all lined with perfluorinated chemicals, because when you put it in the microwave, you're using the water molecules in that popcorn kernel to heat it up. Use it in the microwave, it heats that water up, the popcorn explodes with flavor, and then the water comes out as what? When you cut the microwave bag open after microwaving, what comes out the top? You've all seen microwave popcorn? Steam, exactly. Steam comes out the top. Excellent. Somebody's had microwave popcorn. When it comes out the top, it's kept in that paper bag. Would you put steam in a paper bag if you had a choice? Probably not, okay? So what we line up with these fluorochemicals, which are lipophilic on one end, so we put butter in there with it, heat it to 120 degrees, and then eat it. Is that a good place to put your man-made chemicals? They're all man-made. Probably not. Okay, but even if you manage to lick off the fluorinated chemicals and eat the rest of them, what happens to the bag after you're done? Maybe only 0.1% get into the popcorn. That's not bad. Maybe. What happens to 100% of the chemicals when we toss it in the landfill afterwards? We toss it in the waste, it goes out to the landfill in this country. 100% of that bag will decompose in 60 days in an aerobic landfill. And all those chemicals, remember we call them forever chemicals? These forever chemicals go through the wastewater treatment and into the water that we drink. And this is a problem. There are now 1,400 chemicals in use that we've identified. This is a paper out of Europe that did a very nice study of 200 different categories of where we're using these chemicals. Ski waxes, fluorinated ski waxes, cosmetics, clothing, carpets, lubricants, mist suppression systems for machinery. Everything uses these chemicals, and most of them are non-essential. The last one I just heard, just off the topic, Molly, another student, a graduate student in my lab is studying this, waterproof swimwear. You now have waterproof swimwear. You can get bathing suits that will be PFAS treated. So the marketing is, so you can go from the pool to the bar without a towel. That's an essential use of waterproof chemicals, right? So you don't have to have it dry off because it's dry by the time you sit down in the bar. All right, so there we go. They're environmentally persistent. They're bioaccumulatives. We've heard this all with flame retardants before, but these ones are much more ubiquitous. It's not just 3 companies making it for one particular purpose, a flame retardant. It's 6 companies worldwide making it for 200 different purposes. It's in everything, okay? And it is industrial leases. We have these things at Hoosick Falls. St. Gobain did that. We have it used in the military on every aircraft carrier every day for the last 70 years. They've practiced putting out jet files. And what do they do with the foam after they're done? This is a picture from the Navy's own website. It's since been removed, but the aircraft carriers put it into the water. But it's bioaccumulative. So the fish that eat it get eaten by bigger fish, they get eaten by seals, get eaten by polar bears. And the highest level ever recorded in blood is in a polar bear because it's a persistent organic pollutant, global migration to the poles, and it builds up in the top predator in the poles, which is the polar bear, 188 parts per billion in that polar bear's blood. And he doesn't eat any fast food, right? He's just eating seals, but they're bioaccumulative. So what's the top predator at mid-latitudes? Like where we are. Look left and look right. There they are. Okay. You are the top predator. You eat any foods, you eat any sort of meat, you eat any sort of vegetable that happens to be grown in this water, you have got it in you. And courtesy of this, we also know what happens when it's in you. The disease correlations come out of a phenomenal study done by Rob Balot, who was a lawyer. And it's he discovered that a science panel was convened, and after 12 years, they came up with these recommendations that 6 of these diseases were associated with C8. That PFOA and PFAS. Testicular cancer, kidney cancer, hypertension, and pregnancy-induced hypertension called preeclampsia, then high cholesterol and ulcerative colitis, immune disease. Those are fairly common diseases. Those are big ticket items. As soon as you see that, the lawyers can then sue and claim. They foolishly took the first few to court and lost in a day with millions of dollars of damages and criminal liability in some case. So DuPont quickly shelled out about $600 million, made it go away. Okay, that was the initial one in this area in right downstream from the Parkersburg plant. These things come from the factory. They go into landfill. They get into the water. You put them on crops and you eat the crops, or you put the fire out and it goes in the groundwater. You suck it up and drink it. It goes on food packaging. It goes everywhere, and it gets into you because this continues to circulate until it gets. One of the best ways to get rid of it is actually to have a human drink it, because then it stays in your body for 5 years on an average half-life for the C8. So we know these things are done. We know that those 6 chemicals are positively associated, and there's millions of dollars of lawsuits already settled doing that, but they pass through, which makes them incredibly scary. In addition, we now know, this is a map from the Environmental Working Group of where known contaminated sites are. It looks like Michigan has a bad case of the measles, right? There's a lot of sites in Michigan. Luckily, Indiana, all that PFAS stops at the border and says, oh, this is a PFAS-free state, I don't go there. Do you believe that? Well, North Carolina started looking because of the Cape Fear poisoning. That was a DuPont plant there, and Cape Fear is a wonderful name for a contaminated area. That watershed has now got the state of Indiana, state of North Carolina looking. Michigan has looked. It's the only state out of 50 that has looked at all public water supplies now. New Jersey looked several years earlier. 3M plant, not even Minnesota, but just the 3M plant. New Hampshire has gone and Massachusetts is going. Colorado started looking, California started looking. Those sort of adventuresome states that start looking at their own water supplies. And the rest of these are just known military sites. There are 2,000 military sites where this was used every day, and probably all of them have PFAS plumes. So you imagine that map filled in when we start looking at all the other places. There will be some states without much. There's not much out there, but there'll be, most of these ones will be heavily. Alabama is already suing Georgia over its pollution of its rivers from PFAS. There's public perception. If you've seen this movie in 2019 or this movie in 2018, there's this is big stars, Hollywood stars. We actually got to do a preview of this movie on campus a couple of years ago, right before COVID. But this is a issue on how he discovered and found it from the DuPont plant. It's really quite a provocative story. It's like Erin Brockovich Part 2. And it's really well done. If you look at the number of publications, even as early as 1997 to 2000, there were 6 to 10 per year on this substance. If you look recently, and if you Google search something with health, human health and PFAS, or PFC is the previous name for them, we went through 600. This is early this year, but we'll have over 600, 800 of those articles per year now coming out on the health effects of these chemicals. We've included liver malfunction, hormonal changes, obesity, low birth weights, immune system reduction. That's a big one. Every time you get a vaccine, you are now less likely to have it work because you have immune system reduction. Myself, personally, once I became aware of this, some people who were really experts in the field got me involved in this because I was looking at flame retardants. They said, you should look at this thing too. If you could invent a way of measuring with XRF PFAS, you'd be rich. And I'm still not rich, but I found a way to measure it. And it's not with an XRF. But I joined a policy statement. My first policy statement ever published. I just signed up with 16 other people who helped write it, and we said we call on the international community to cooperate, limiting the production and use of PFAS in developing safe and non-fluorinated alternatives. That's a statement a scientist can make. How many people read this? Well, at least 200 of us that signed it, but the rest of the world didn't really read it. But it's something that we can do. We can say as scientists, this product really shouldn't be used. There are examples of its urgency where it really could be used. Ophthalmic surgery. If you're going to have a retinal reattachment, you use this stuff as to float the eyeball in because it's inert. Okay, that I could see, but that's a 55-gallon drum per decade to cover all the eye surgeries we ever do with it. We don't need a tanker truck per day of it coming out of the factory in Texas because we want dry swimwear. It just makes no sense that we use it on everything. Let's save it for when it's essential use and then try to do this. This is our facility at Notre Dame. This is the 9S accelerator, St. Andre accelerator in the basement of physics. And we have this method of telling popcorn bags from copier paper. Isn't that great? I can put 2 pieces in the beam in 180 seconds. I can tell you whether it's fluorinated or not. And if we look for organofluorine, we look for things that shouldn't have fluorine in them, like clothing or paper, and we can see it right away. And the students, some of them are here, actually get to run this, and they do a wonderful job of screening for them. And with that tool, we then published some papers. And we were pretty intentional about picking these papers because this one was done with fast food packaging, and it was student driven. Students said, hey, can I put the Jimmy John's wrapper in the beam? And we said, sure. We were looking at textiles at the time, and the Jimmy John's wrapper was fluorinated. We're like, oh my gosh, let's see how many others are. So we did a study of about 500 papers, and they were from all across the United States. Volunteers collected them for us. We put it in the beam. We said fluorinated, fluorinated, not fluorinated, not fluorinated. And we came up with a list. We didn't say which companies were, but all the major companies, where 20 of them were in this paper, we found, and it hit the news stores. 142 news stories came out on this thing in the Washington Post. And we had a onion satire saying, I'll never eat another wrapper again. Good. Yeah, I've never been an onion satire before. It's kind of fun, but it was fun. We had our ride in the sun. This was a newsworthy event, and all 20 companies that were named in this article received a letter from Senator Blumenthal's office in Illinois, and he said, "I understand from the Washington Post you're using this chemical in your packaging. Can you respond? A, when will it be removed? And B, are you using it in your packaging? And B, how soon will it be removed? What's your company policy on these chemicals, and how soon will it be removed?" And when you're getting a sitting U.S. senator sends the CEO of a company, Panera, Starbucks, McDonald's, Arby's, all these companies got this letter, what do you think they did? You call in the vice president and say, make it go away. I don't want to deal with this. I certainly don't want to be in a congressional record on this. And so we have pretty convincing evidence that 20 out of 20 companies switched out of this stuff very quickly. McDonald's has publicly announced it, eliminating it by 2025. They're covering their bases. Okay, but they've actually removed it from all the packaging we found. They had, in fact, a policy in place beforehand, but they'd forgotten that French fry boxes also had it. And we found it not only in their French fry boxes, but all the rest of the companies have never admitted using it. They just started switching away. And it was easy for them because there's an alternative they already use. They use plastic liners and with paper. They use double wrappers. Some of them obviously use foils. There's ways to get away from it, and they just moved, and they made a decision. It was done in 18 months, which is quicker than the first regulations, which took about 2.5 years. Oregon has a regulation. The state of New York has a regulation. Rhode Island has a regulation. And California has one now, which is 3 years later, which is that they not use in any government packaging, any government procurements of these packaging materials. So all in about 18 months without any rules in place for a long time. So that was policy that happened as a function of a paper. And we feel really good about it because none of the companies really complained. They just did it. I'm sure it was annoying and I'm sure it was an expense, but they change the wrapping 3 times a year anyway because it's Christmas season or whatever season, pumpkin spice season right now. Okay, so they changed the wrapping anyway. They just switched to a non-fluorinated brand and it was fairly new to them. They had only just started using it. Only about a third were using it. So they've switched away from it. Are there other cases? And this is where I got a heartfelt letter from a firefighter's spouse whose husband was diagnosed with cancer. And this is the "What Do You Fight For" video. They have a tremendous cancer rate over the general public. About 2 out of 3 firefighters will die of cancer. Used to be heart attacks that killed them. Now it's cancer that kills them. Okay, and the average American, only 1 out of 3 dies. So this is an elevated rate of different types of cancer. Look at that, testicular cancer right up there. That's one of the things that PFAS is known to be for. So the question is, are they exposed from all this? And there's elevations in their blood. We have, courtesy of these chemical companies, about 5 parts per billion in our blood today of all these chemicals. You're North Americans, mostly. You'll have about 5 parts per billion. Okay, and that's because of something you ate or because of something you've been drinking or because of, and there's a variation. Everybody has higher or lower. Here's South Australian firefighters, and their average is 12 instead of 5. And that's typical in American firefighters too. You have higher blood lead levels of these PFAS. But look at this guy up here. This bloke is at about 1,600. And so that got the author of this article to go out and meet him and say, why was he at so high levels? Was he drinking the Kool-Aid? Was he drinking the AFFF? Why? Area, and they gave them all cooking classes so they could eat healthy. So they ate all organic in this place, and they raised their own grain and they fed it to their own chickens, and they got organic eggs out of their chickens and they ate it. And this guy was in a bottle building regime, so he's eating 5 egg yolks a day to build up protein. And guess what bioaccumulates the most PFAS of all? It turns out the grain, which is a great sucker up of PFAS, was grown right where the test pit was where they tested the PFAS. It was in the grain, it was fed to the chickens. Present PFAS, this material is made waterproof and water resistant with PFAS. So yes, it's in the gear at percent levels, not part per million, not part per billion, not part per trillion, but percent levels. Does it come off? Yes, at part per billion levels. We found, you'll notice my students are wearing the nitrile gloves because we found without the gloves on, they could transfer it to their hands just by handling the gear. Do firefighters handle their own gear with gloves on? Nope. So that was one other thing. Does it get into the firefighter? That's a good question, which we didn't answer in our paper, but we have ongoing studies to look at both dust exposure and dermal absorption. And when our study came out, not so many people read it because it's mainly for firefighters, but we did a correlated dust study in fire stations, and both these came out within about 6 months of each other. And the good news about this is that the firefighters were finally told that their gear had it, was the union got on board. The International Association of Firefighters represents most of the firefighters in this country, and they comment on the study and they say the research, in addition to other studies, says we need to make this a priority for our members. And what followed up was two resolutions in January of this year at the big firefighting meeting, where they voted on these two resolutions to actually ban the companies that made the gear from their annual conference, which was a huge cost because they paid several $100,000 to come to the conference, but they were going to give up that $100,000 until they made PFAS-free alternatives. That was PFAS-free. They had read the tea leaves and had actually marketed this about a month after our paper came out. The other three companies all decided within that week that we're going to do it too. And so the whole industry, there's only 4 companies that make this gear in the US. All 4 of those companies have now agreed to switch to PFAS-free simply from the union getting really angry. And they're angry because they weren't told there were any toxins there. These guys run in burning buildings. They know what risk is. They just weren't told that there was a risk in their gear. I will stop about there. We did do a recent paper on cosmetics, and guess what? These cosmetics are sure enough full of fluorine, and we published it on the same day that a law was passed in the Senate, and a few days after a House bill did the same thing to try and ban PFAS in cosmetics. This is now the most downloaded environmental journal article in this journal to date. It went viral in 3 months. We have 334 news stories on that, and there's still more going on. We just showed that it goes directly into the user, but it can also directly go to everybody else from the landfill. And that's our idea, that these cosmetics and other products are being used and that PFAS stays forever. It's a big viral publication. What happens to this? I don't know. So far, not a lot. The bill in the House passed, of course. The bill in the Senate is stuck in committee, and that's where the chemical industry is fighting back, and it's never going to come out of committee. That's where you stop these bills. Maine has banned it, but that's one state. You can't put PFAS in cosmetics or anything else there. Several companies have privately reached out to me and my co-authors to say, well, how do we get rid of it in our supply chain? Which is what an environmentally conscious company will do. They'll describe that what they want in their cosmetic, what ingredients, and they'll want it PFAS-free. And that's a great step, that we know that this is happening. Same thing is happening. And it just shows what I'm going to conclude with. Scientifically, what I'm going to do next, I'm going to try and commercialize this. This is tech transfer. We want to do this rapid screening more. I don't want to screen every product. I'm tired of screening cosmetics. I want a company to take this over and do that sort of stuff. But I would like to watch scientifically where the fate and transport of these things go. That's where I can add new scientific knowledge, and my students can work on that. I can identify new sources and sinks of these things. I can identify new chemicals. We just found we didn't find it, but we think we found a brominated azodye, which is a mutagen and an endocrine disruptor in black dye. Can you think of anything textiles dyed black? Oh, you're wearing a black shirt, Jonathan. That's nice of you. Black leggings. Ooh, okay. So we're thinking that we have identified new chemicals to wash. The policy aspect that I'm going to encourage any scientist or potential scientist in the room to think about is this is education. We have to teach people about these chemicals and why they're concerning. We have to figure out who is against the change, because you don't like to be sideswiped by somebody. When you do all these petitions and you realize the chemical industry, the flame retardant industry was funding $26 million a year lobbying to keep this stuff legal. When you came in with a bunch of pathetic scientists trying to argue that it should be illegal, it doesn't help. But once you know who's against your side, then all you have to do is sort of uncover, and when the light shines on it, the cockroaches run away. And it's possible to get change to happen. In the US, this is different from Europe. Market pressure is much more important than regulation. Regulation, we don't regulate in this country, we litigate. And litigation is a powerful force. Fear of lawsuit will get things to change. But market pressure will bring that to bear much quicker in any country than legislation. Legislation takes 8 to 10 years to go through. And at that time, we're still eating this stuff. And communication skills are essential. Being able to communicate to your policymaker, being able to, how do you describe to a parent that their child might be lead poisoned? You have to think about that. It's not something I do in my lab. And I really am not good at it. I don't want to do that. But I can design tests where people can do that. And so these are the sort of take homes. I'll be glad to talk about those. This is the people that did all the work and the funding for it. It's just an application of nuclear science that my group does. But in applying it to public situations, we are sort of standing out front and saying, this is what we should and shouldn't do. And for the most part, we're aiming it at the mid-level managers, the companies that make these decisions. And they're like your friends. Most of them will make the right choice if they're given the option. There's always one or two companies that I don't understand. They'll always go after profit over ethics. Okay, but if you give people the ethical choice, most of them do the right thing. And that's true of most of the industries we've dealt with so far, but not all. And I'd like to thank all the students who are doing all the work. Lots of undergraduates involved in this too. I didn't put their names up there, but Molly will wave. And thank you for your attention. I appreciate you coming.